What happens when the densest object in the universe gets eaten alive by the darkest one? Let's dive into a cosmic horror show. Imagine a cosmic showdown between two extreme objects, a black hole and a neutron star. As they spiral toward each other, the intense gravity of the black hole distorts their surroundings, like a funhouse mirror. This event can create massive quakes, rifts, and fascinating light shows, offering insights into the universe. At Caltech, scientists used supercomputers to simulate these dramatic cosmic encounters. They discovered that before a neutron star is consumed, it undergoes violent processes triggered by the black hole's gravity. These simulations predict radio and X-ray flares, which could be observable before the neutron star disappears. Neutron stars and black holes often exist in pairs, engaged in a cosmic dance. While both are born from supernova explosions, black holes are heftier remnants of massive stars. Eventually, the black hole usually devours the neutron star. Simulations reveal how this process unfolds, showing how the neutron star's crust cracks like an earthquake, producing detectable light. Researchers visualize the powerful outflows created during these mergers. As the neutron star is consumed, a black hole pulsar may emerge, resembling a classic pulsar that emits radiation. This simulation captures how such an exotic object could form during this cataclysmic event. They also studied the aftermath of the neutron star's demise. When consumed, it generates enormous shockwaves, the strongest in the universe, which send out signals detectable by telescopes. The simulations show two potential signals right before and during the collision. Despite advancements, observing these mergers remains challenging. LIGO scientists aim to detect these cosmic events up to a minute in advance, providing a larger window to capture the light and gravitational waves produced. The progression of the simulations relies on advanced supercomputers. The massive computational power enables scientists to model these intricate cosmic interactions more accurately than ever before. As a neutron star approaches a black hole, its crust shatters, sending out waves. The black hole also interacts with the neutron star's magnetic field, displaying characteristics that mimic pulsars, albeit for a brief moment. As physicists continue unraveling the mysteries of these celestial dances, they hope to extend findings to other binary systems. Each cosmic clash brings us closer to understanding the universe's most powerful phenomena. Keep an eye out for further discoveries and advancements in this exciting field. Join the journey of exploration and wonder in our universe. If your mind just imploded like a collapsing star, hit that like button and subscribe to @LightLeapLabs, where curiosity bends space and time.